Warner. Welcome back to the podcast episodes that we're shooting here at IMS 2023 in San Diego. Today, I'm joined by Daren McClearnon, who is a product manager as part of the Keysight EDA division, and we're going to talk about some exciting announcements they have, particularly as it pertains to RF and microwave technology. So, Daren, thanks so much for joining and
yeah, thanks for having me.
Pulling yourself away from meetings in the booth to tell me what you guys are up to. So, what is Keysight focused on specifically in your product group that has to do with RF and microwave?
We're here at the show for a new release of Pathwave ADS 2024. There will be an announcement tomorrow. I think what we're focused on is the evolving complexity of design processes for millimeter and microwave design. Chip design and module design have some significant trends that are just technology disruptors. Right. So I think the overall picture is the complexity of densifying and making very small and power efficient, heat efficient, these structures where we're packing more capability into smaller spaces with less power. So we have several new features in ADS 2024 that are driven by the values of helping people make progress to deliver their designs faster, on time, and with the performance that they intended at cost. So there's several key areas that we've been messaging, and again, that's all going to be announced tomorrow.
Excellent. So I've been talking to a few people at the show specifically about millimeter wave. It seems to be a hot topic. And one of the things I'm hearing, and I'm curious about how Keysight's addressing this, is that as we move into millimeter wave, that there are those unintended consequences. Mm-hmm. Sometimes I call it the whack-a-mole. You hit this and then something else pops up over here, right? And so is that true when it comes to modeling and simulation and things that ADS handles, that maybe there's new techniques and things or things in the tool that will help sort of mitigate those issues?
There's absolutely, and I think the overall trend is toward density, of putting more capability in a smaller volume, to fit in handsets, to accommodate a lot of the rich data experiences that people want to have. One of those consequences is electromagnetic interference. We all lived in closer quarters in COVID. You can hear your neighbor electromagnetically, signals nearby or on other floors in your microwave building.
Yes.
And also thermal. If there's a power amp nearby, it's like a loud party. It affects everybody. Also, some of the performance that's being driven is also very tough to put on one IC. A lot of times there's specialized PA or functional things to support. So it takes a village. There's lots of different chips and technologies that need to go in one package to make a successful, point of presence or handset, front-end module. And so when you take different technologies, pack them, flip chip them, put them in place, you're having to do fine microwave design or millimeter wave design, but with multiple companies and partners in mind. And so that dealing with, it's one thing to design your thing.
Right.
It's another thing to assemble many things in one spot.
Right.
So one unintended consequence of electromagnetics and these packaging technologies is stability. Of, if I think something is ground, but it goes through a bunch of layers and ends up here, and my power supply comes from a weird place, and I'm distributing it, the sneaky ground pass through the lids of things and through the floor walls, you end up with you think you're designing a power amplifier, but it's actually got lots of ways to get signal back to ground.
Right.
And you have to account for that. And same way with thermal. If I have a PA that's heating something up, anything in the nearby area is also going to be contaminated with that heat,
Right.
and its performance will droop. And so how do you predict what everybody's doing in the presence of these extra influences?
Right.
So predicting that stuff, anticipating it, and fixing it before you actually tape out a chipset or commit to a module is just really important. So the code design is an interesting challenge.
Right. And I certainly hear that from the engineering community, which is what inspired me to do the ecosystem. And Keysight does that better
Yep.
than anyone I know, because you do look at the whole end-to-end through
Yep.
EDA and the test and measurement.
Yeah,
so you have
exactly.
data, right? You're not guessing, and you're hopefully not playing that whack-a-mole, or you have that data sort of in your digital sandbox first
Yep.
before you commit it to design. So, well, ADS is always kind of the rock star of this show. So where can our listeners find out more about the release and more about the features and things like that?
There's at Keysight.com, there'll be the usual landing pages. Our announcement goes out tomorrow. There's also more in-depth things on our website about Keysight University for lots of not just product announcements, but also walking through things about stability, modulation, electromagnetics, electrothermal. There's an electrothermal sequence that'll be up soon.
Great.
So we've got improvements coming on that help EM to account for all of these things and use multiple EM engines on multiple technologies at the same time.
I see.
And actually right-size the problem instead of throwing, here's my big problem, and you dim the lights trying to solve this gigantic problem.
Right.
You can pick out the particular trace or area that you want to simulate and validate it without having to create a bunch of temporary files and setup. You just click this, it simulates, and you simulate a smaller problem. And the use model's quite a bit better.
That sounds like a gift, really,
Yeah.
with the complexity engineers have to deal with today.
Yeah.
Well, thank you so much for stopping by and telling us about it. I'll make sure to get those links from you and share it with our audience. But again, I know you're so busy, and again, your booth is over there booming with traffic. So wish you well in the show, and thanks so much for stopping by.
Thanks so much.
Appreciate it.
Appreciate it.
Thanks so much for our listeners for joining. We'll see you next time. Until then, remember to always stay connected to the ecosystem.